I'm Leo Lara. I want to talk here about Chiquito. That is a project we started building very recently, just in March, and in February really. And yeah, this is a bit about me. After this amazing introduction I don't know if I should talk more, but yeah, I've been in software engineering for 20 years. I had many lives in software engineering, embedded software, distributed systems, a startup founder, and now I'm really loving to work in Ethereum and in ZKP, and I'm currently working on the zkEVM for the Ethereum Foundation, and all come from that. No? I'm kind of new to the space as a software engineer. No? I come to a space that is like ZKP is a very, currently is still like a small bubble, and I see like this is kind of the dynamic, like there is like currently very bleeding edge research being done in academics, and some really genius programmer kind of create proof systems from that, and there are like some even more genius people that are kind of from the proof system being able, that are very raw, being able to kind of build ZKP circuits. And kind of the average programmer, my team, everyone is super smart, but for idiots like me, the average programmer, we kind of are losing there. No? Like there is not like a bridge to work on that. And that bridge is kind of like what I believe is going to help us to get like to the infinite garden of ZKP. That is like, we cannot imagine still kind of all the implications and all the doors that ZKP is going to open. But to get to the infinite garden, we kind of have to reach to the average programmer. And how do we do this? There is kind of two approaches. No? There is the approach about creating generalistic zkEVM of kind of already known architectures, kind of like I think in this style, like the most known project, perhaps RISC-0, no? That is like RISC-V, kind of processor with ZKP, so you can compile your program to RISC-V, and then you kind of create like zero-knowledge proofs of that program, and this kind of creating better tools to directly create ZKP circuits and applications. So I'm going to talk about the second approach. I think both have to coexist, because also for the first approach we are going to need the second approach, and we will build in more and more complicated and more advanced zero-knowledge things as it become possible. As the performance of zero-knowledge advanced, more applications will become possible, and we will need to go to the bleeding edge to build these applications. And for that, kind of proposing kind of like, we need to provide the developers kind of a tool chain for the average developer to build zero-knowledge programs. From my work on the zkEVM, like zkEVM is for the Ethereum Foundation zkEVM is being built on a proof system called Halo2, but as I say, like that's like very raw for a program this size. Like zkEVM is probably one of the biggest ZKP circuits being built currently. It's impossible to right away, just on top of the proving system, build these so huge circuits. So when I arrived to the team, I saw there was like this treasure trove of abstractions that has been built ad hoc to be able to build what we want to build. No? There is this thing that they say, like in the toilets of Berkeley, someone wrote, I'd rather write a program to write a program than write a program. No? So it's, when you get to this level of complexity, it's inevitable that you need to build these abstractions. And what we are doing with, what we are doing with Chiquito is kind of taking all this abstraction and put it in a nice package so the average developer can use it. No? So we already have like kind of a working prototype that actually can work on the zkEVM. The backend is Halo2, and kind of the front end is in Rust, no? And can coordinate with other Halo2 circuits. So I want to show here some examples. Are there? You can see this is one of the rules in the zkEVM among like more than 6,000 rules. Okay, And if you see at the top, if you try to, this just one rule, try to write it in pure Halo 2, that's kind of like the code that you get, no? And then with the tools that already we have built for building the zkEVM, it's kind of the code that you can see here at the bottom. I hope I'm not hiding it, yeah. So this is the code that you can see at the bottom. It's kind of like already with the abstraction we have, it's much more readable, it's much less confusing, no? And now with Chiquito that we have built, it just like result in these few lines of code, and it's just much better, and it's going to enable to the average programmer to use the tools that we are using for building the zkEVM. So it has been architecture in different phases, DSL, an abstract system tree, and a compiler that compiles to embedded representation and then gets translated to Halo 2. And this kind of enables us to do really, really interesting stuff like kind of being able to add a Python frontend. So there are some people working on a Python frontend in Chiquito, so you will be able to create these ZKP programs in Python, and also we will be able to use different proving systems, and we will be able to kind of connect these elements with debuggers, optimizers, profilers, and that way kind of create like a real toolchain where like a really real toolchain that is very powerful that enables programmer to create like more bigger and more complex ZK applications. So yeah, all these things that we can see here, like the readability is really improved. How it can like teaching ZKP it has been improved by Chiquito terribly. Like we can see an example, for example, in Chiang Mai recently we have this hacker house from Antalfa. Hi guys. Now they are doing a hacker house here in Montenegro, and like people, students that weren't too new to ZKP, they could start building like proving hash functions in ZKP with Chiquito like right away. So this kind of enables us to get to the real infinite garden of ZKP, like where ZKP is not like this small bubble, but actually there are like a whole industry with many developers creating public good open source software. So comparing with other kind of ZKP languages, we have been doing some research, and this we see that this is kind of like the most high-level ZKP language that exists nowadays. No, like if you compare like kind of like these are more like C, these other Noir, Circom are more like C, and this is more like Python. It's going to be much easier to use all these high-level abstractions for the average programmer. So this kind of like the vision, the general vision of all this project is kind of like perhaps like PyTorch for ZKP. AI is exploding right now, and one of the reasons is like a few years ago they started to appear these tools like PyTorch that enable kind of much easier access for developers to start building AI tools and AI technologies. Thank you for your attention, and if you are interested in the project, please join this Telegram group, and we will be doing some session here in Podgorica in the next day, on the other day. Okay, thank you very much.